Hello everyone. I'm happy to come back to this channel to teach you about significant zeros and significant numbers. It's something that is quite challenging. Most people doing mathematics, people who are doing chemistry, when they are making calculations in numbers. So I want to give a general overview about significant numbers and significant zeros. My name is Enoch. Don't forget to like my channel, subscribe on my channel. Don't forget to share my video. Alright, let's go through rule number one. Rule number one talks about the zeros in between numbers. For example, 94. Let me get a pen here. For example, we have 94.072. We have a zero between numbers, other numbers. So this is very significant, or it is significant. We have 94072. It is also significant. So in this case, that means we have 5 significant numbers. Here we also have 5 significant numbers. Then if the zero is leading, or we have what we call the leading zeros, like these, we have 0.0. These first zeros, we refer to them as leading zeros. In this case, they are not significant, meaning that if you are to talk about the number of significant numbers, or the significant numbers here would be 834. That means we have 3 significant numbers or figures. Then we have rule number 3, the zeros at the end after the decimal point. They are also very significant. Like in this case, we have these 2 zeros. They're significant, meaning that in this number we have, let's count the number of significant figures. This is 1, 2, 3, 4, 5, 6. So we have 6 significant figures. Then we have rule number 4, when we have zeros at the end of a number. They may be significant or they may not be significant. If it is a measurement, then they are significant. If it is just a number, then they may not be significant. We have a number here, and we need to find out whether the numbers given here are all significant, or we have some zeros that are not significant. For example, here we have 45.876. Everything here is significant. Well, that means all numbers count. That means we have here 6 significant numbers. We have another number that has 0.00. There are 3 zeros. These are 3 leading zeros. So these are not significant. That means the significant numbers here are 239. That means we have 3 significant numbers or figures. When we come to this, these first 3 digits, or the first 3 zeros, are leading zeros and they are not significant. But these after the decimal point, these ones here, after the numbers, are very significant. That means the number of significant figures here are 23900. That means here we have 5 significant figures. Then we have 48000, and we have a decimal point here. So all these numbers are significant. 48000, those are 5 significant numbers. Yet in this other number here, it's only 2 significant numbers or figures. The 000 here, they are not significant. Then we have 3982. All these are significant. So we have 4 significant numbers here. And then here we have zeros in between numbers and even after. All these count. So we have 1, 2, 3, 4, 5, 6. 6 significant numbers. Right. So they all count. They all count. They all count. Alright. So that's a small summary of what I've been talking about in here. All digits count. The leading zero don't count. Trailing zeros, these are the trailing zeros, they do count. The zeros are before the decimal point, they all count. In this case, these ones, they do not count. Here, all digits count. And then here, all these zeros count, including the trailing one. They all count. So we come now to a very important aspect whereby we deal with the multiplication, the divisions. Here we have a rule, and we say that this rule states that in carrying out a multiplication or division, the answer cannot have more significant figures than either of the original. So that means you need to consider the number of significant figures in the figures that you're manipulating. So, like in this case, we have 278. These are 3 significant figures. I can use a different color. Let me use a different color. Let me use blue. For example, here we have 3 significant figures. Here we have 4 significant figures. That means our final answer cannot be below a 3, and then cannot again be above 3, because this number here we have has only 3 significant figures. So if you get your calculator and divide 278, let's get our calculators. 278 divided by 11.70, you find that you're getting an answer like 23.7606837.6. The number is continuous. So we have these numbers, and one may struggle to find what should I write. But in this case, the values that we have, one has 3 significant figures, another has 4 significant figures. So we consider the one that has the least number of significant figures, which is 3. So that means we shall write up to 3 significant figures. So that means our answer will be 23.8, and that will be our final answer. That is based on the significant figures. Then we come to rule number 2. Here we are adding, and I want you to take note of this. We are considering the significant figures and number of decimal places when we are adding. When we are adding numbers that have decimals, this is the rule. So we are saying that, for example, the rule number 2 says that your answer should only have the same number of unit placing as the most imprecise number. So this is the most imprecise, this is more precise. Alright? So this has 3 decimal places. This has 2 decimal places. That means we shall write our answer to only 2 decimal places. That's why we're adding, and we're having, first of all, 0.021. These are 3 decimal places. But because our answer should be compared to the number which is more imprecise, which is 0.1, so we shall write 0.02 to 2 decimal places. Let me just give you another number just for you to try out and see if you are getting the concept. For example, if you have 0.11 plus 0.1, I'm giving you just some few seconds to get the answer. So one may rush and say that I'm getting an answer which is 0.21. Yes, you're getting 0.21, but when you're dealing with such numbers and you're adding, we look at the number which is most imprecise, and in this case this is 0.1, which is to 1 decimal place. That means your answer should be written as 0.2 as your final answer, basing on the significant figures. So when you are making your calculations, please put that into consideration. When you're doing investigations, put that into consideration so that you get your mark for the calculation. Then we have numbers, for example, 90,000 plus 900. In this case, we don't have decimals, or we don't have points in our numbers. And in this case, one using his calculator may get 90900 as his answer. But in this case now, you look at how many significant numbers are in the numbers you're adding, and then we consider the least number of significant figures. Like in this case, we have only 1 significant figure. Even here we have 1 significant figure. So if you have 90900, it means here that you have 3 significant figures, and we want our answer to be to 1 significant figure. That's why we are writing 9000. So that puts you at an advantage that you are following the significant figures rules. Then we come to this last part, which is very, very interesting and very tricky, and we shall analyze it together and find out whether we are really getting the concept. Look at the number of significant figures in either number and then judge what will be the correct answer. For example, in this case, we have the first number here. This has 4 significant figures. This has 3 significant figures. That means your answer should be to 3 significant figures. I said this has 4, this has 3. So your answer should be to 3 significant figures. So that means we shall have 49.7. That would be your answer. Then we come to another number here. This has 3 significant figures. This has 4 significant figures. So that means our answer should be to 3 significant figures. 464. Then we come to this other number. This has 4 significant figures. Remember, this is a trailing 0, so it counts. And this other number we have 1, 2, 3, 4, 5, 6. So we have 6 significant figures. Here we have 4 significant figures. That means our answer should be to 4 significant figures. And this is 1, 2, 3, 4. Remember, these are leading zeros. They don't count. So our answer will be in that way. It will be just as what we have here. Let's go to the next part. I'll pause a bit and ask you to find out the answer. I'm pausing just 30 seconds. I hope you have found the answer. Let's see if you have got the answer. Okay, so you can decide to pause this video for a while and then make a calculation before you can see or review the answer. Okay, now let's check again and see. This has 1, 2, 3, 4, 5. 5 significant figures. Then this one has 1, 2, 3, 4. So the least significant figures are 4. So that means our answer should be to 4 significant figures. So 1, 2, 3, 4. That will be our answer to 4 significant figures. Lastly but not least, you can decide still to pause the video and then try it out. As time is against us, I'll try to calculate it out, but you can also try and review. You can stop the video several times and do it until you're perfect. In case you have questions, then you can ask me. Then we have this other number. This has 1, 2, 3, 4. 4 significant figures. Let's check this one. 1, 2, 3, 4. 4 significant figures. That means our answer should be to 4 significant figures. So this is 1, 2, 3, 4. So it will be 1.000. So we have 4 significant figures. So in case you are confused, you don't know exactly what to do, you may decide to contact me on my WhatsApp. Feel free to contact me. +250 785 183 043. So you can decide to contact me via WhatsApp in case you are stuck in the calculations, especially the area of analysis of your data. You don't know, you are adding up things, they're not working out. Please feel free to contact me. My next video will be talking about the uncertainties, specifically in the chemistry and also their implication. So we shall be dealing with calculation of uncertainty in chemistry. So feel free to check on my YouTube channel to find out the next video. Thanks for watching. Have a nice day. Bye bye. Bye bye.